Alright, hello. Today we have this question before us. It's a competition level problem and a relatively hard one at that. However, it doesn't require any advanced knowledge to solve. So, let's look at what it says. Positive integers a and b are coprime, which means they only have 1 as a mutual factor. And this fraction, this expression here is an integer. And we need to solve for a and b. Okay, so these are our two conditions, and now let's think about some things that we can get from these two. If this fraction is an integer, one thing we can instantly get is that the denominator must be a factor of the numerator. And it also means that every single term, every factor in the denominator is also a factor of the numerator. So we know that a here is a factor of the numerator. And obviously a is always a factor of 4a squared, so whether or not this whole expression is able to be divisible by a, we only have to look at this part with b. So we know that a has to be a factor of 9b squared. Now again, a and b are coprime, which means that they have no common factors except 1. So that means that a is not a factor of b. In fact, a and b share no common factors except 1. So a must be a factor of 9. There is no other way for a to be a factor of 9b squared. A is a factor of 9. And because a and b, a is a positive integer, this means that we can narrow it down to only 3 options. A can be 1, 3, or 9. Now let's do the same thing for b. b is also a factor of the numerator. And b is always a factor of 9b squared, so we have to look at 4a squared. b is a factor of 4a squared, and again they are coprime, so b is a factor of 4. We are doing the exact same thing that we did for a. And b is a positive integer, which means that we have these 3 options. And we can even further rule out one of the options by looking at the fraction. One thing we'll notice is that for AB, this thing, the denominator, is always even. So in order for the fraction to become an integer, the numerator also has to be even. And 4a squared is always even, so 9b squared must be even, right? But in order for 9b squared to be even, that means b has to be even. And if b is even, that rules out 1. B cannot be 1. Which leaves us with only 2 options for b. And here we have, to summarize, a can be 1, 3, or 9, and b can be 2 or 4. And there are 6 possible combinations, and we can simply try all 6. Here I've listed out all of the possibilities, and as well as calculated the fraction. Here we have these 3 as integers and the other 3 not. And we are looking for cases where the fraction is an integer, which means we have these 3 answers right here. So a and b can take the values 1 and 2, 3 and 2, or 9 and 2. Now there's a follow-up question. Well, we've solved this problem, which is great, but there is a follow-up question for those of you who are interested. And the follow-up is, why does b never take the value 4 in our solutions? If we go back, we'll see that b is always 2 in those 3 solutions. And whenever b is 4, it seems that we simply cannot get an integer. So we need to understand if this is always going to be the case, that no matter what value a takes, whenever b is 4, we don't get an integer, and why, right? So this is a follow-up question. Please post your answers in the comments if you managed to get it. And I hope you've learned something from today's video, and I hope to see you next time for another one.